All right, so here's our second part of quadratics, and that's finding the axis of symmetry. So remember back to when you guys would graph things like this, right? Because you have this big coordinate plane where it's kind of like you're given an equation or you're given something and you're told to graph it. Well, you really don't know where to start, but in this case, you guys always learned that, oh, if you know that b is 3 or the y-intercept is 3, you can go to the point 0, 3, you can put a dot, and then you can use your slope to go up 2 over 1 and just keep making your dots until you get your line, right? And it kind of helped take this big graph and narrow it down to a little section so you're able to graph it. When we graph quadratics, like you guys learned in the previous section, they either open up or down. And again, they're going to be graphed on the coordinate plane. But a quadratic can be over here. It can start right here and go like this. It can be over here, right? They can go like this. They can be anywhere on the graph, right? So it's a little bit more difficult to figure out, oh, so where am I going to graph this, right? And you have all of these numbers to pick from, right? You guys knew that, again, like if you had something linear, you could just always take like -1, 0, 1, plug them in and see what numbers you got and then plot those points on the graph, right? You can make a table of values. You're also going to be able to make a table of values with quadratics, but you kind of need to find a middle point, okay? And the axis of symmetry, what that does is that tells you the point where you split the parabola in half and you make the left side equal to the right side. All right, so it's important to find that because if you find the axis of symmetry, it kind of gives you your starting point for graphing. You need to find the axis of symmetry because it's going to give us the x value in our vertex. And our vertex is the highest or lowest point in any parabola, okay? That's your vertex. All right, so the first step in finding the vertex is being able to find the axis of symmetry. So today we're going to work on the axis of symmetry, and then tomorrow you're going to take that axis of symmetry and be able to find the vertex of these functions. All right, so there's a formula for the axis of symmetry, and it gives you the x value. So when you're thinking of axis of symmetry, it's always x equals some number, okay? And then you take that value and you plug it in to your equation, and it'll give you your y value, and then that would be how you would find your vertex, which, like I said, that's going to be our lesson for tomorrow. So today we're just working on finding that x value, okay? Finding our axis of symmetry. All right, so in the first problem, we've got y equals x squared plus 2x plus 3. Okay, so again, it matches our form. What we need is b and a, or the opposite of b, okay? It says negative b, but remember, we always talked about just saying the opposite of b. I think of it that way because if b were negative, then the opposite would be a positive. All right, so you need a and the opposite of b. So a is 1, b is 2. So since we want the opposite of b, that's going to be -2. Okay, so our two numbers we're using are -2 and 1. Plug them in. X equals -2 over 2 times 1. -2 over 2 equals -1. So x equals -1. So the axis of symmetry for this function, y equals x squared plus 2x plus 3, is x equals -1. And what that means is that if we graph this at -1, there would be a line that did that. And we know our parabola opens up, so we would go, it would be symmetrical, on that line opening upward, okay? So today all we're doing is axis of symmetry. And in the box, you're just gonna have to type what number the axis of symmetry is. So in this case, if it's -1, you're just gonna type -1 in the box, okay? No x equals, no anything like that, just the number for the axis of symmetry. All right, so let's go over a couple more examples together. Okay, the next one. Y equals -1/2 x squared minus 2x plus 2. Okay, a is -1/2. Opposite of b So we're going to say the opposite of b, the value that we're going to use is 2. Okay, because in this case, b is negative 2. So the opposite of negative 2 is positive. So we're going to plug these into the formula. X equals 2 over 2 times negative 1/2. X equals 2. 2 times negative 1/2 is this, which becomes 2 over negative 1. And 2 over negative 1 is negative 2. So in this case, the axis of symmetry is negative 2. All right? Okay, let's look at another example. All right, y equals x squared plus 4x. Okay, a is 1. The opposite of b in this case would be negative 4, because b is 4, and the opposite of that is negative 4. So x equals negative 4 over 2 times 1. X equals negative 4 over 2. X equals negative 2. So the axis of symmetry for this problem would be x equals negative 2. All right? Okay, and the last one. Y equals negative x squared plus 4x minus 5. A is negative 1, and the opposite of b is negative 4. Okay, so we have negative 4, so x equals negative 4 over 2 times negative 1. X equals negative 4 over negative 2. X equals 2 would be our axis of symmetry. All right, so when you're doing the axis of symmetry, make sure that your function is written like this. As soon as it is, identify what A is, identify what the opposite of B is, plug them in, and solve your equation. Okay? All right, again, if you guys have any questions, let me know. Again, on the Google form, you're just going to write the number. You don't need to type in x equals, just do the number. All right? Okay, keep working.